Can the sound insulation be improved in lightweight concrete dwellings? Let's take a look at this. I got this question the other day, and my guess is that this sounded like someone having problem with bad sound insulation from their neighbors. So let's say it's on the bottom floor like this, that we have a concrete foundation. I'm not a structural engineer, so I'm not sure how you draw concrete, but I think it's something like this. We just to clarify, concrete. And then there's lightweight concrete walls. Oops. It's always a bit strange to write with this electronic pen. But I'm gonna get used to it sooner or later. So I would guess that this is probably a combination of both impact and airborne sound insulation. And in this case, we will only consider the flanking transmission this way, and the transmission that comes straight through the wall like this. Now, there's probably some parquet floors on both sides, and now we don't know the thickness of this plate. It's unknown to me, but and usually if this is also apartment separated wall, there probably should be something like this, I guess, also to take care of the load. And now if this one is very thin, the thickness is very thin, you're gonna get a lot of sound transmission this way. This one needs to have an adequate thickness, and I would say, like for Swedish requirements, perhaps 200 millimeters would be a safe bet in a dwelling, because then you can use some kind. You also should put something elastic beneath the parquet flooring on both sides, like this. And let's also clarify, parquet like that. And maybe if it's an old house, maybe this one is thin. What if it's just like 100 millimeters in the foundation? That's the word I'm looking for. And then perhaps it's old, so this elastic interlayer, the green here, maybe it hasn't aged nicely. So perhaps this one has become almost stiff, and that means you're gonna get a lot of walking sound coming through the foundation. Now, to get a good improvement of this sound transmission path, ideally you would want then to put a premium impact sound insulation mat here. There are very good products that are like 5 millimeters thickness, but if you only have a proper layer on, let's say we fix this one over here, but if the disturbance is coming from here, the problem is that if you only do on one side, you're still gonna get the energy from a footstep or dragging a chair or kids playing with their toys. The vibration, structure-borne sound will still enter the building foundation and travel in here, so you're still gonna get sound in there. So you would need to do it on both sides. You're gonna get a little bit of dampening from this, but it's I don't think it's enough. A big, very important rule of thumb with acoustics and with anything else in life, for that matter, is to always fix the problem as close to the source as possible, because the further down the chain you attempt to fix the problem, the more expensive it's gonna be, and the lower the quality of the solution as well. The closer the source that you fix the problem, it's cheaper and better. So if you have impact sound insulation problems, you need to put the mat preferably where the impact sound is generated, not where it is received. Now this is one of the problems here. And then we have a second thing to consider as well. So let's take a look here in... Oh wait, sorry, that's the wrong screen. I'm gonna move it to this side. Now I think we have it. Yeah, there it is. Here's a typical concrete wall. Let's say it's 200 thick is a common in Sweden. And you got a reduction index here of 59 dB. And if you look from 50 hertz, you get 59 minus 2, so 57. If this would have been lightweight concrete, you see it now, the size changed as well. So, but anyways, 45 minus 1. And the requirements in Sweden is 52 minimum. So even if it's 200, it's still not enough if it's only lightweight concrete. And if it's a thinner construction, let's say 150, so 42. I mean, now this is even worse than a conference meeting room. So it's not a wall construction that is nice as a unit separation wall between dwellings, because if it's only 40-ish, then you're going to hear a lot of sound from your neighbors. So the solution in that case, that would be, I guess, a separate framing structure. We need to construct something like this, and it should not be attached here. We need to make a timber, let's see, right timber stud and air gap. Now we're talking here. And then I would put something here which is regular gypsum boards, perhaps 2 layers. You see what happened with the sound reduction index? We got a massive improvement here. So now this would work as a unit separation wall, but there is a negative here. The thickness increases, of course. So now I'm just, what's it called? I'm just shooting from the hip here. So it's not a detailed solution by any means, but the principle is valid. This is what you want. A separate framing structure. You should not let it touch here. It must be an air gap. And then the bigger the air gap, of course, the better the sound insulation is going to be. But then there's also a compromise. How much floor area are you willing to sacrifice for the improved sound insulation? And if we then go back to this one, let's say that we improve the wall construction with a separate structure like this and some mineral wall, then we can fix this one. So it's gone. It's gone. But it's a massive reduction. But when maybe we still have this problem with a foundation. If it's a thin foundation, you're gonna still get the flanking transmission here. So even if you have a monster wall here, a really, really good Fort Knox sound insulation wall, the chain always breaks at its weakest link, and in this case it would perhaps be the floor structure. So even if you fix the wall, maybe everything is just gonna go that way instead. I guess you could consider it an analogy. If let's make it like an electronic circuit like this. If you have, let's see if I remember how to draw this. I've studied electricity, but circuit theory maybe is the word. Like we have 2 resistors like this, R1 and R2. This could be sound analogous to sound transmission paths in a building. So maybe one of them could represent the floor flanking transmission, and the other one could represent the direct transmission through the wall. Now let's say that this R1 equals 1 mega ohm and R2 is 100 ohm. Where's the current gonna go? Well, it's gonna get very little current here because this resistor is huge. So just about everything is gonna go this way. So there is no point to increase R1 to 10 mega ohm. It's not gonna change anything because the current will just go this path instead. And yeah, that's perhaps a bit of sad news, but yeah, it's physics. Can't do much about it. That's the way it is. And in today's video, I'm wearing a navy blue jacket, gray shirt, orange pocket square, and some green pants. And this is the cool one, my nicest belt. It's a burgundy colored leather belt, really, really nice one. And I think this one goes. It's an underrated color, so don't forget about the burgundy style. I think it's beautiful with navy. This one looks fantastic with a nice navy blue suit, and then I have a pair of shoes that has the exact same colors with matching medals on the shoes as well. So that's a really good fit. But the difficulty is when you're looking for a belt, you need to find one that is have the exact same color. See you later.